Good morning, all of you. I hope you've understood the previous classes that we have done. And in today's class, this is almost the last part of the chapter. We will be in today's class. We will be doing the exercise questions, and this is a very small activity which is left. So let me first cover this, and then let's move on to the exercise question. Okay. So now that you have understood what is atmospheric scattering and how is that the sky looks blue, why does the sky looks orange or reddish in color in the evening and in the mornings, let us also understand this activity. It actually tells you why the color of the sun that you see sometimes is yellowish, or in the noon time it appears a little white to you, or in the evening it appears slightly reddish or orangish in color. So very small activity. What they have done is, in this activity we have taken this is a source of the light, the S here. So this S is the source of the light, means the white light will be flashed through that source, correct? Now, and then we have taken two converging lens. Okay, converging lens means, suppose if the light is flashed from focus, if the light comes out from focus, then after passing through the lens, the light is going to travel straight, which means parallel to the principal axis, correct? Now look at the other lens, the second lens here that we have placed. Whenever the light is coming parallel and falling, when it is incident on the lens, what happens is, because it is a converging lens, it is going to converge all the light rays onto a particular point which is known as focus, correct? Now, in between, we have actually taken a tumbler, and in this tumbler, we have added clear water plus some concentrated sulfuric acid. Now, what is the point of adding sulfuric acid? Sulfuric acid has got sulfur particles, and these particles are strong enough to scatter the light, the white light which is incident, correct? So, in this solution, as I told you, you have the sulfur particles. So when this white light is incident, okay, the sulfur particles are going to scatter the light. And when this light is scattered, then you will see blue color from all the three sides. This side also you will see, if you see from the top, you will see blue color from the bottom, and all the three sides you will see blue color light, because blue color is the easiest, that light is the weakest one. Okay, it has got, the wavelength is not so much, and the sulfur particles will be able to scatter the light. Okay, but the strong light, which is red, which is orange or yellow in color, that light will be able to pass through the lens successfully. Okay, only blue gets scattered. That's why you see the entire color of this water, you will see it blue, correct? Only red and little orangish light will actually pass through the lens. So what type of color will you see on the screen? You will see red plus slight amount of yellow. So in the center you will be see crimson red color, not a very pure red color, but crimson red color is what you're going to see here, and around the crimson red you are going to see yellow light also, correct? So that shows that when the white light is coming from the sun, and only the blue light gets scattered, and when those rays enter our eyes, what we see the sun either pure white or yellow or orangish in color, because the only color which is getting scattered is only blue, right? In the daylight, I told you, in the noon time, why do we see it white in color? Because only the blue light gets scattered. So suppose if this is the sun, okay, and this band of light is coming. Now this is where we are actually observing the light. So only the blue light gets scattered, here. That's why we see the sky blue. But all the other colors are still in this ray of light that is traveling. So when we see all this band of colors, when you combine all this band of colors except blue, you will see generally bluish or slightly yellowish sun. That's why in the noon time, so it is what we perceive through the eyes. If we see through the eyes, if we see the ray which is coming and which is entering inside our eyes, if we see these band of colors in which most of the blue has been scattered, and if we combine all these colors like the red, the orange, the yellow, the green, and the lower colors, so when we look through these colors, ultimately we will be able to see whitish and yellowish, sun. That's why during the noon it is white in color, slightly yellowish in color, right? So this is a small activity which shows, which makes you understand as to why do we see sun in these particular colors. Okay, so this was the last activity which was left. Okay, I'll take up the question after we finish this. Some students have put up questions, so we are going to take those questions just in a while. Okay, fine. So let's now move on to the exercise questions. So, and these are the questions. The first question is, the human eye can focus objects at different distances by adjusting the focal length of the eye. This is due to, and then 4 options are given. So as you know, the human eye is able to focus the objects which are close to our eyes, and as well as the objects which are at certain distance far from us. Okay, so this is because of what? This is because of, this is nothing but it is the power of accommodation of the eyes. So option B is correct, the power of accommodation of the eyes, because it, and the power of accommodation comes because of which part of the eye? It comes because of the ciliary muscles. The ciliary muscles will expand and the ciliary muscles will contract, because of which the shape of the lens changes, which helps us to see the distant object as well as a nearby object. Okay, this was pretty easy. The second again says that, I'm sure you will be able to answer this question also. The human eye forms the image of an object at its dash. So where does the human eye forms the image? The human eye forms the image at retina. Okay, because retina is the screen of the eye, of the human eye. Fine. Next one is the least distance of distinct vision. Distinct means clear vision. Okay, for a young adult with normal vision is about. So what is the clear vision? Clear vision and the least distance. Which is the least distance of the normal eye? It is 25 centimeter. It is 25 centimeter. And what is the far point I told you? The far point is infinity. The far point is infinity. These 2 points are very important. Okay, so these are the multiple choice questions that you have. Next one is, the change in the focal length of eye lens is caused by the action of dash. Now what makes us to change the focal length of the eyes? What out of pupil, retina, ciliary muscles and iris, which is the one? Is it pupil? No. Is it retina? No. Retina is the screen of the eye. So it is the ciliary muscles which helps us to change the focal length of the eye. Okay. Now, next one is, a person needs a lens of power minus 5.5 diopters for correcting his distant vision. Okay, so for correcting his near vision, he needs a lens of power plus 1.5 diopters. So if he needs to, what is given in the question? If he needs to correct his distant vision, he needs minus 5.5. If he needs to correct his near vision, he needs plus 1.5 diopters. What is the focal length of the lens required for correcting both the distant vision as well as the near vision? So what is given to you in this question? I told you, anytime you are given a question, you have to very clearly write down what is the given data, okay, available to you. So what is the data given to us? The data that we have is, for distant vision, we have power as minus 5.5 diopters. And this is the next power, which is the power for the near vision, which is plus 1.5. Okay, this is what is given to us. What is he asking? He's asking, what is the focal length for correcting both? So you are given power, you are supposed to find out the focal length. So is it easy? What formula will you use here? The formula for power. Okay. So the formula for power is 1 upon your, the formula for the focal length is 1 upon your power. So just have to divide 1 upon power and get the answer. So look at this. What I've done is this is the first power. Focal length is 1 upon power. So focal length, when I calculate minus 1 upon 5.5, I get minus 0.18 meters. And the second one also I've calculated the same way. I've just divided them. So here the focal length is minus. So which means it is a concave lens. Here in the second case, the focal length is plus, which means it is a convex lens. Okay, it is a convex lens. So this is also, it was easy, I hope, for all of you. Okay, let's see the next one. Now this is very important. I want all of you to clearly understand the question first, and then let me know the you should tell me, write it in the chat box, and tell me what is your V and what is your U in this case. Okay, now the question is, the far point of a myopic person is 80 centimeter. Okay, so there's a myopic person, the far point is 80 centimeter in front of the eyes. What is the nature and power of the lens required to correct the problem? So he's asking what type of lens will you use. Okay, so what is given to us is a myopic person. What is myopia? It is nearsightedness. So write down very clearly, then only you will be able to understand. What is myopia? Myopia is nearsightedness. What is nearsightedness? Means he can see near, but he cannot see far. So he wants to see. How far does he want to see? He wants to see infinity. At infinite distance he wanted to see. Right? But he can see near, but he cannot see far. Okay? So he cannot see at infinity, but he wants to see at infinity. Fine? So what type of lens and the nature of the, what should be the nature of the lens and what should be the power in order to look very clearly, in order to look far. Okay? Now what is given to us is that the far point of the myopic eye is 80 centimeter. Okay, this is the far point, means this is the maximum that he can see. 80 centimeter is maximum he can see, but he wants to see infinity, but he only can see 80 centimeter. Fine. So in such types of questions, yeah, some of you are writing very correctly. Very nice. U is going to be infinity and V is going to be minus 80. Now I'll tell you why for the others who have not understood. In these types of questions, remember that whatever the eyes want to see, that you should keep it as U. Okay? He wants to see. So U will be whatever he wants to see. Okay, whatever he wants to see, that will be your U. So in this case, what does the eye wants to see? The eye wants to see infinity, distance, right? So your U will be infinity. Okay, but in this case it will be minus infinity, because understand that if this is our eyes, then the U, which is the distance, the U is on the left hand side of the eye. So it has to be minus. It has to be minus. Okay. Now next is whatever the eyes can see, that is going to be your V. So what this is, V will be can see. So what is can see? How much distance he can see? He can see 80. So again, it will be 80, but please add a minus sign here. It will be minus 80. Got my point? So just remember this. Whatever the eyes wants to see, that should be U. Whatever the eyes can see, that will be your V. So now it will be simple. So you got your U, you got your V. You have to just substitute in these values in 1 by f upon 1 by v minus 1 upon u. Okay. So when I substitute, okay, why have we kept wants to see as infinity? Because only after you place, suppose you have to place some kind of lens here, either a convex lens or a concave lens. You have to see some kind of lens and also keep the object at infinity, and then see that whether after putting the यार मत करना यार
देखो मैं ऐसे इतने से शो में थोड़ी कुछ होता है।
Okay, so next is so what I've done is I've already solved it for you. Look at this. Now here 1 by f is equal to 1 by v minus 1 upon u. So your f is minus 80. So your power will become minus 1.25 d. 1.25 d. Okay. So your power is minus 1.25 d. Which means what kind of a lens is this? Because now you can see your focal length is minus. So when your focal length is minus, then it is going to be a convex or concave. Tell me quickly. If your focal length is minus, it is going to be your concave lens. Write it down. Okay. Fine. Okay. Next question we have is the similar type of question, but in this case, the person is not suffering from myopia. The person is suffering from hypermetropia. Okay. Now, look at this. Make a diagram to show a how hypermetropia is corrected. So all of you can draw the corrective measure. How can we correct hypermetropia? Okay, all of you can draw the diagram. We have already done it in the defects of eyes. The near point of a hypermetropia is 1 meter. So what is given here? First of all, hypermetropia. So write it down. Write down hypermetropia. Okay. So what is hypermetropia? Which means far-sightedness. The person can see far. Okay. The person can see far means he is able to see at infinite distance, but he cannot see near. Okay. So he wants to see near first of all. He wants to see near. Okay. So now I told you your U will be wants to see. Your U will be wants to see. So what is your wants to see here? What distance do you want to see in this case? You want to see 25 centimeter. Okay. Because he is not able to see 25 centimeter. Only if he keeps an object at 1 meter, he is able to see it clearly. But he wants to see any object at 25 centimeter. So your U will be 25. And again, it will be minus 25 because all the objects which are kept outside the eyes are, on the left side. So you will place a minus sign there. Correct? Now, V is what he can see. Okay, what he can see. So what distance he can see? He can see minus 1 meter. So now again you can substitute these values in the formula and find out the answer, which I've already done it for you. Look how we've done it. What I've done it, this is the formula. 1 by f is equal to 1 by v minus 1 upon u. Then you have what is u? U is 25, which is minus 25. So this will become plus 1 upon 25. Okay. And v is minus 1 upon 100. Once you solve it, you will get your power as 0.33 diopter. Your power will be 0.33 diopter, which means it is a positive power. Okay. Focal length was also positive, power is also positive. So positive means what kind of lens is this? This is going to be a convex lens. This is going to be a convex lens. So this is how you got to understand. So it is easy. Whatever he wants to see is going to be your U. Whatever he can see is going to be your V. Okay. Now, and all of you know how to correct hypermetropia. We've already done it during while we were studying the defects of the eye. So draw that diagram here. Now, next is a student cannot see a chart which is hanging on a wall placed at a distance of 3 meters from him. Name the defect. If a student is not able to see a chart which is hanging at just 3 meters from him, so what kind of so that means here the student is not able to see far. He should be able to see infinity. He should be able to see infinity, but he is not able to see even 3 meters. So he cannot see see far. He can only see up to 3 meters. He cannot see far. But he can see near. He cannot see far. He can see near. I want you to write down the defect. I want you to write down the defect in the chat box. Yes, correct. Very nice. Very nice. It is myopia. It is myopia. Okay. So this, I hope is so like similarly, you know, the questions can be given to you. A person is not able to see at, let's say, at 25 centimeters. He's only able to see, you know, at 1 meter. So what kind of a defect is? Very nice. It is myopia. Fine. So which means the defect of the eyes, and you can make out what kind of defect is this person is suffering from. Very nice. Now the next question is, why is a normal eye not able to see clearly the objects placed closer to 25 centimeter? Now do you understand the question? Why is that the person is why is that we are not able to see anything which is closer to 25 centimeter? Why is that? If we place anything which is closer to 25 centimeter, it gets blurred. Why? It is basically because of the ciliary muscles. The ciliary muscles can only contract and expand to a certain limit. It is not able to contract or expand beyond those limits. And what are those limits? Those limits are only such that we are able to focus objects between 25 centimeter to any distance which is placed at infinite distance, right? Between that only the ciliary muscles are able to contract or expand. Suppose what will happen? Suppose if we keep the objects very, very close to 25 centimeter, because the ciliary muscle is not able to focus clearly, it is not able to contract or expand, then what will happen is, then the object will become blur, right? The vision will become blurred. Okay, so that is the reason, because it has got only certain limits to which it can contract or expand. So this again is very important question. Okay, next. What happens to the image distance of the eye when we increase the distance of the object from the eye? The question is, what happens to the image distance of the eye when we increase the distance? So you know that within the eye, suppose if this is the eye as shown here, so where is the image formed? The image is formed at the retina. So which means there is one particular distance which is fixed. There is one particular distance which is fixed. Okay. What is that distance which is fixed? This distance is fixed. This is V. V is fixed in the eye, inside the eye, which means it is a distance from the lens to the retina. V is fixed. So he's asking, if we place the object, if we move the object from this position to a second position here, if we displace the object, what is going to happen to the V? V should change. If U is changing, V should change. So why is that what happens to the V? So the question is, can this distance between the answer to the question is, you have to tell me, can this distance between the lens and the retina ever change? Because eye is going to be the same. The size of the eye is the same, right? So can that distance change? No, that distance will remain same only. So if V is not changing, then if we move the object, how are we actually, how is that formula of 1 by F is equal to 1 by V minus 1 by U? How is this satisfying? Your V is not changing, but your object distance, your U is changing. So what is the solution? The solution is that when your object distance change, the lens will become thin and thick and will try and change the focal length. Okay, so when your object distance is changing, the lens will become thick or thin and it will change the focal length. So remember that your V will always remain constant. V will always remain constant. It will not change. It is if you change U, then your focal length will change. If you change u, then your focal length will also change. How will the focal length change? The focal length will change because the ciliary muscles will help the lens, the eye lens, to change the focal length. Okay. So look at this answer. First is the image distance in the eye does not change. This is first thing. It does not change. The image distance remains the same. Second is only the focal length of the eye keeps changing. So the focal length keeps changing because of the power of accommodation that we have. Okay. The image distance remains fixed and the image is formed on the retina. So image distance does not change. What is that which changes? It is the focal length which changes. If you change the object distance, the focal length will change and accordingly adjust to that object distance. Okay. So this is what happens to the image distance. Nothing changes. No image distance will change ever. Fine. So now that we understood that, these are the last two questions that we are going to do, and after that we are going to wind up the class. Very important questions. You have to make a note of all these questions. In fact, this is the important one. The question is, what is the maximum? Please add here focal length. Okay. This is focal length. Okay, here. What is the maximum focal length of the human eye? So I want to know what can be the maximum focal length of the human eye. Next is but natural question is what is the minimum focal length of the human eye? So two things very important, and let us just understand how to solve them. So now we know the formula 1 by f is equal to 1 by v minus 1 by u. We are supposed to calculate the focal length and we are supposed to calculate the maximum focal length. Okay, which means if we are looking at an object which is placed at infinite distance, if we are looking at an object which is placed at infinite distance, then what is going to be the focal length? Okay. Yeah, okay. Devesh, just hold for some time. Let me just finish these two questions, then I will take up questions, okay? So now, we know that what is u? U is infinity. Okay? U is minus infinity. What is our v? V is going to be the same, which is plus 2.3 centimeter. Now, where this 2.3 centimeter comes here? 2.3 centimeter, I've told you initially while in the first class while studying about the human eye, the diameter of the human eye is 2.3 centimeter, which means that the distance between the lens and the retina, this distance is 2.3 centimeter. What does this distance become? This distance is nothing but our v, which is not going to change. Okay, so the distance is 2.3 centimeter, which is your v. So we know our v, which is 2.3 centimeter, which we also know our u, which is minus infinity, because minus infinity is the maximum length that we want to see, so as to calculate the maximum focal length. So we know these two figures. If we substitute these two values in the given equation, we will get 1 upon plus 2.3 minus, then it will become minus 1 upon infinity. Okay, so this term is going to cancel because it is going to be 0. We will be left with, on the left hand side, 1 upon f is equal to 1 upon 2.3. 2.3 is going to be positive because it is on the right hand side of the lens. Okay, next, so what is going to be your focal length? Your focal length is going to be 2.3 centimeter. So this is going to be your maximum focal length of the eye when you want to see maximum distance. Okay, please make a good note of this question and the next one. So this is clearly understood by all of you. Our u is minus infinity and our v is 2.3. How is v 2.3? Because it is the distance between the eye lens and the retina, which is never going to change. So in both the cases, we are going to take our v, the image distance, as 2.3. Only u is going to change. Okay. So now let's move on to the next question here. The last question is, what is the minimum focal length of the human eye? Now same steps we know what is our V. V is 2.3 centimeter. What is our U in this case? U is in this case is going to be, what is the closest distance? What is the near point of our eye? The near point of our eye is 25 centimeter. But 25 is going to be minus 25. Okay? 25 is going to be minus 25 centimeter. Okay? Now, if you substitute these formula, just give me 5 seconds. Okay, so yeah. So what is the formula? The formula here is 1 upon F is equal to 1 upon V minus 1 upon U. Just substitute these values as 2.3 centimeter minus, then you'll have 1 upon, this is 25 centimeter and this is minus 25 centimeter, right? So this will become 2.3 plus 1 upon 25. Okay, if you solve this value, you will be getting, try and solve this value by your on your own. You will be getting F is equal to 2.10, or it may differ in points, but most of you will get this. Okay, most of you will get 2.10. So what is the minimum focal length? The minimum focal length is 2.10 centimeter and the maximum focal length is what we calculated before. Okay, which is 2.3 centimeter. So you must know that our ciliary muscles are able to contract and expand and change the focal length between this figure. Okay, so that is about the chapter. Now we have